Okay, I'm being waved. Apologies. I'm being waved at. I am the person holding us up. So welcome back. This session is about how GA4GH interacts with the other standards setting organizations kind of in our bailiwick or our general geography. It's great to have such a great selection of people here. And we start with Robert Freimuth from HL7. He has been working in medical informatics for a long time, and he is currently at the Mayo Clinic exploring how to leverage EMRs for both clinical practice and for research. So Bob, tell us about HL7.
All right, thank you very much. As Ewan said, I'm going to be talking about some of the work that we're doing in this space from HL7's point of view, and then I'm going to conclude my talk with a little bit of a relationship of how HL7 is working with GA4GH as we lead into the other panelists that are part of this session. So in the interest of full disclosure here, I am a co-chair within HL7 Clinical Genomics. I am also a co-chair within GA4GH GKS, so I will be wearing both hats as part of this presentation. And I do receive funding from the NIH, including that from the ClinGen resource, which will come up later as well. So for those of you that may not be as familiar, HL7 is an organization that develops international standards for clinical systems, including EHRs. They are very widely adopted. They have a number of different product families, including the very widely implemented V2 messaging standard, CDA, and more recently the FHIR specification. We're going to be talking about FHIR primarily today. It's a large organization consisting of more than 60 different work groups, and unfortunately, I don't have enough time today to give you a rundown of every single one of those, so I'll just stick to the one, which is clinical genomics. Clinical genomics has as its goal to develop standards to facilitate the exchange of clinical and translational information that relates specifically to patient genomic data and its related clinical information. There is a wide variety of people that participate, which provides us with a great spectrum of viewpoints and use cases and requirements, and that all comes back to help us make our standard more robust and more comprehensive. There are, as I said, a number of product families within HL7 shown in the columns here. The CG work group has developed a number of specifications in each one of these. Anything in black is essentially unsupported at this point. The ones that are in red are under current active support. I'm going to today focus on some of the work that we're doing in the space related to FHIR and the development of our domain analysis model, which is essentially a collection of use cases, and the corresponding domain information model, which helps us to provide common semantics across the communications amongst ourselves, and which will ultimately be used to help provide a common underpinning semantic alignment across all of our specifications that are developed within HL7CG. So beginning now with FHIR, which stands for Fast Healthcare Interoperability Resources, the focus of FHIR is on the implementer. So the intent here is to help decrease the time that it takes to cycle between development and deployment, to make it more efficient for developers to create these apps and deploy them. FHIR is based on standard internet-based technologies, which means developers can utilize the wide array of tooling that already exists in this space and leverage that as part of the development and deployment of applications for healthcare. This also helps us to achieve wider and broader portability, not just within dedicated clinical systems like EHRs, but also within other applications and systems like mobile devices, which natively support these internet protocols. FHIR is widely supported by many vendors already. The major EHRs are already implementing FHIR-based APIs as part of their products, even as the FHIR specification itself continues to mature. So there is a bit of a moving target here, but it is being widely supported by many different vendors. And then the interoperability that is intended to come as part of FHIR comes because of its development of predefined resources and APIs. And those resources themselves are what represent the clinical concepts. They are what is being exchanged, the data that's being exchanged from one system to another. These resources define the content model, including the structure, which would be the relationships of elements of those resources within itself and to other resources. And one of the things that's really attractive about FHIR is that the human readability factor is so good that domain experts that really aren't very technical in nature can have a firsthand can participate firsthand in the development of FHIR-based applications, including the specification itself. And this allows them to bring their expertise much closer to the actual development process. FHIR uses a compositional-based approach to information modeling, which means we are intentionally creating building blocks that can be then used to build up bigger and bigger structures with more semantic nuance. We are not trying to boil the ocean here because we would never get done. We are simply targeting what's considered the 80-20 rule, where we are looking at what's considered to be the most common 80% of requirements from the most common use cases. Anything beyond that can still be supported, but it would be supported through the development of a profile on top of some of those core resources. And so these resources and profiles turn into the building blocks that are then used to assemble into larger and more complex structures. And what I have here on the right-hand side is simply a pictorial diagram that shows how the underlying core resources, shown in purple, such as diagnostic report, observation, and service request, can be customized for particular use cases, shown in blue, through the profiling mechanism. And so within clinical genomics, we have developed a profile over diagnostic report to represent a genetics diagnostic report, which we can then link to genetic observations and genetic test orders, and through this mechanism, use the core FHIR resources while at the same time achieving some additional specialization that's required for the genomics domain. If you're interested in learning more about the work that we've done, you can go here, build.phir.org, and take a look at our implementation guide. That's the IG in that title. This is a work in progress, so if you go here, you can see something that will be changing dynamically. We are currently in the process of resolving ballot comments from our version 3 to version 4 and beyond. So this will continue to evolve and continue to update based on the feedback that we get from our users and participants. The implementation guide itself contains a number of different sections to it, including the definitions of those core components that I just mentioned with the specializations for clinical genomics, as well as some information and examples related to specific use cases within clinical genomics, such as for cytogenetics, pharmacogenomics, and cancer or somatic testing. Now, structurally, the way this looks is the blue box on the left represents our genetics diagnostic report. You can see that there are arrows linking off to those green boxes on the right, which represent the customized profiles based on observation. And so what we have as part of our model is that our genetics diagnostic report can reference observations that will allow us to define things like a genomics testing panel and genetic test interpretations, impacts, and genomic findings. I'm going to skip over this slide for the interests of time, but I'm going to pause here for just one moment and point out that one of the interesting things about FHIR is because of this tension and this balance between trying to adhere to standards-based core resource structures, which will enable interoperability and data to pass through one system over another, even if that system doesn't support a customized profile like it might for genetics. The tension between achieving that level of support and achieving the richness in the semantics that we need to be able to capture and encode genomic data leads to a very interesting conundrum, and that is that much of the semantic structure that we would otherwise model in a very structured, nuanced, interconnected way in a genetics-based information model gets completely flattened out into a giant big bucket of attributes as shown here, and it goes off the bottom of the slide. And so we as a work group and within the FHIR community are currently going through a process of where we are kicking the tires on this and trying to achieve a balance between how much of that core resource do we support natively and want to adhere to so that data that passes through a system doesn't drop on the floor, compared to how much are we going to potentially break that default interoperability just a little bit so that we can get more semantic nuance and structure out of the information itself. One of the things that makes FHIR so easy to pick up and start playing with is the tooling and the test servers that come along with it. This is a tool called ClinFHIR, which was developed by David Hay. It's publicly and freely available. You can come on here and play with it. Down the left-hand side, you can see this is a web-based tool. It has a number of different modules that you can click on. One of them is called the Scenario Builder. And this is just a screenshot of how you can get started with that. You can go in here and you can start adding resources to your scenario. And each time you add a resource, the tool will go out, it'll read the structure definition for that resource and bring that in and display it on the right-hand side of the screen so that you can see very easily which attributes are required, which attributes are optional. You can go in, you can click on these and put in test data, and you can check it for validity. And you can see I've added, in this particular scenario, I've added a resource to represent patient. I've added another one to represent a single observation. And what's really neat about this is that in real time, the tool will start assembling these things into the FHIR message itself. And so it will show you a graphical depiction of the resources and the data that you've started adding to this tool and the way that it connects to each other. And you can even see if you're more of a developer type, you can go into the JSON message itself and take a look at the structure and how it's being built out. And as you can see boxed off in red here, I've entered in just some example test data showing a genetic test result for a TPMT metabolic activity measurement with the value being ultra-rapid metabolizer. And all of those are coded values that come from LOINC. So to get this data in there, I had to go through about 3 or 4 clicks to get the resources loaded. I typed in about 4 characters of LOINC codes and the rest auto-completed. And after just that simple exercise, I was able to produce this fully FHIR compliant JSON message. So this type of tool is at your fingertips and ready and able to be used if you just want to start playing with it. Another product that we're developing within the clinical genomics work group is our domain analysis model document. Now, this is a document that has passed what's called the informative ballot within HL7. It passed that late in 2017. It is available for HL7 members. You can log on to the website and download it right now and take a look at what's in there. If you are not an HL7 member, the embargo period on this expires later this month, and so after that time, you'll be able to go to the website and download it and take a look at the content. Now, the DAM that we have here is actually a bit of a misnomer. There's no M in it. It's completely missing a model. It's really a collection of use cases that span the bullet points that are shown on the left here. There's 100 pages of this, so if you're looking for some interesting reading, you can go take a look. These use cases essentially outline the requirements and the type of data elements that we are trying to capture in these specifications that we're producing in FHIR, in V2, etc. Now, in order to flesh this out and add that M back in, there is a separate but related activity that's going on within HL7 that I happen to lead for developing that information model. And we're taking the entities that are listed here on this slide, and we're constructing information models that will help provide a common semantic backbone across all of our HL7 CG artifacts. And we will be adding this into the domain analysis model document as we get this complete. Now, I know after a little more than 2 days, you are all energized about participating in GA4GH, and you have already mentally committed to investing more time and effort into this organization, and Ewan thanks you for that. But I know after seeing all of this, you are also saying, boy, that looks like a lot of fun. How can I get involved? And you should. So there are a number of ways you can engage with HL7 clinical genomics. The easiest is simply to go to our webpage and check out our meeting schedule. We meet 3 times a week by teleconference, 3 times a year in person. The next one is coming up in January in San Antonio, Texas. There are also connectathons associated with this, so as you start kicking the tires on FHIR, if you want to see how that interacts with other servers, you can join a connectathon and go through some scenarios. Now, since you have all memorized the goal statement for the GKS workstream, I know when I put the equivalent one up for HL7 clinical genomics, you immediately thought to yourself, wait a minute, that sounds risky because they're 2 organizations that are both trying to do very similar and overlapping things, and you'd be absolutely correct in thinking that. Fortunately, the organizational leadership on both sides of that particular fence have come together and agreed to work together on the development of pre-harmonized standards that will help to minimize this overlap and minimize conflict. So we have a goal between HL7 and GA4GH of informing each other's development. Of course, what we're trying to do is avoid the situation, I'm sure you've all seen this comic previously, where we develop competing and overlapping standards that make a mess out of the adopter community, and then we have an effort after the fact to come back in and clean it up with yet another standard. And so we're going to be avoiding this, and we're going to be working proactively in more of a unidirectional fashion. Now, I'm leading now into the rest of the panelists' talks. What we have here is a simple pictorial description of a level of formalism, and as you move to the right on this graph, we increase both the level of formalism as well as the level of potential interoperability, and the vertical axis is time to development. I have arbitrarily placed several organizations on this map, as you'll see in just a minute. The formalized certified SDOs would be in the upper right-hand corner. The point-to-point academic lab-to-lab collaborations would be down in the lower left-hand corner, and consortia that are primarily based in the research domain would be somewhere in the middle. The idea here is that organizations like HL7 and GA4GH and driver projects like ClinGen can all work together in this space and work together in harmony. The way that this works is that organizations like ClinGen, like the eMERGE network in the US, are really closer to the cutting edge of science. That's where the use cases develop, that's where the urgent needs are, and that's where the initial thinking by the boots on the ground type people are working. That information can be passed through and up through these other standard development organizations, and if we do this right, that can be done in a harmonized way as opposed to a competitive way. And we already have examples of this working functionally in ClinGen, which of course is a driver project for GA4GH. There is a data exchange work group. It's led by Larry Babb somewhere. The thinking and the work that we've done as part of the data exchange work group has informed a lot of the modeling that we've done here in the GKS workstream and in the ClinPheno workstream as well within GA4GH. And that in turn is being passed into HL7 to help inform the development of our FHIR specifications and our information modeling at that level. And so by coming together and forming a collaborative environment as opposed to a competitive one, we can really leverage all of the work that's going on across this continuum as opposed to end up with a competitive space. And so with that, I'd like to pass the microphone over to the next panelists. Thank my co-conspirators both within HL7 and GA4GH, and I thank you for your attention.